Hello everyone and welcome to my channel Ghiloo once again. So in this video I'll be discussing the entire exercise 5.3. So let's get started. Here from question number 1 to 8 you can see here there are two variables which are intermixed with each other. Means there is no separate expression for y and an x. That means y is not directly a function of x here. These kind of functions are known as implicit functions. So here basically from question number 1 to 8 we will be performing the differentiation of implicit functions. So without any further delay, let's get started. So coming to question number 1, let us start from question number 1. The method, there is nothing specific. You need to differentiate both the sides and then you need to arrange dy by dx in one side and hence you will find it. Given, let us first write in this way and then we'll be differentiating both sides with respect to x. We get, and here it is d by dx of sine x. Solving this, we have d by dx of 2x plus d by dx of 3y by the fundamental rule of differentiation, and d by dx of sine x is cos x. So therefore we can easily have it as 2 plus 3 dy by dx is equal to cos x. That means we can have dy by dx is equal to 1/3 of cos x minus 2. This is our required solution. So in the same way you need to do up to question number 8. I am just hinting, I will not be solving it in a methodological way like this I am doing. In question number 2 you will be just differentiating both the sides once again. You can differentiate with respect to either x or y, that's your choice, but make sure to find dy by dx at the end. If you find anyhow dx by dy, just reverse it to find dy by dx, that's all. So here you can do either of the two. Either you can take the derivative by d by dy or by d by dx. In either of the cases the answer won't be different. Similarly in question number 3 you will be doing this. Let me do question number 3 once. So it is a plus 2by dy by dx is equal to minus sin y dy by dx. This will be the expression after differentiating it with respect to x. So after assimilating the dy by dx we will be getting the expression. In a similar way question number 4 is also the same. You differentiate with respect to x. In question number 5 also you differentiate it with respect to x, and remember that here you have to apply the UV rule of differentiation. It will be 2x, it will be x dy by dx plus y plus 2y dy by dx is equal to 0, and therefrom you can assimilate it. So in question number 5 it is nothing but just 2x plus x dy by dx plus y plus 2y dy by dx is equal to 0. Now you can assimilate dy by dx from here very easily. And the same is the case with question number 6. Once again you can see x square and y here and x and y square here, so these two are going to be solved by the UV rule of differentiation. Similarly with question number 7, it is an implicit function once again. To solve it is very simple, just differentiate both sides with respect to x. So here you have sine square y, that gives you 2 sine y, and by chain rule the differentiation of sine y is cos y, and once again the differentiation of y with respect to x is cos y dy by dx. Plus, now how will you differentiate cos of xy? That will obviously be minus sine of xy times the differentiation of xy. Now the differentiation of xy with respect to x will be solved by the chain rule. Now by the UV rule. So here you will be applying x dy by dx plus y. This is equal to dy by dx of pi. Since pi is a constant, it is 0. Now you can assimilate dy by dx from both the sides and then you can interchange it to find dy by dx. In the same way you have to solve question number 8. This is a very easy one. Starting from question number 9, these are just the differentiation of inverse trigonometric functions. Now you have learned some rules. If you don't know the generalized method for solving the differentiation of inverse trigonometric function, please refer to the NCERT. It is detailed discussed there. In question number 9 we are given the function y is equal to sine inverse of 2x by 1 plus x square. Please remember these are some standard forms. If you have something inside of inverse in this form 2x by 1 plus x square, what should inevitably come into your mind is to shorten it, to summarize the entire expression into a single one, you can do that by assuming x is equal to tan theta. So that's how we will start. Let x is equal to tan theta. So what is the benefit of that? So therefore 2x by 1 plus x square is equal to 2 tan theta by 1 plus tan square theta. If you observe closely, it is 2 tan theta by sec square theta. Now 2 tan theta by sec square theta is 2 tan theta times cos square theta, because 1 by sec square theta is cos square theta. That gives you 2 into sin theta by cos theta, which is tan theta, times cos square theta. So cos theta and cos square theta gets cancelled by a factor 1, and that gives you 2 sin theta cos theta, which is sin 2 theta. So eventually, just by assuming x is equal to tan theta, you can reduce it. You can reduce the expression 2x by 1 plus x square as sin 2 theta. Now you know that sin inverse of sin 2 theta is just 2 theta. Now 2 theta is very simply, you can write it as 2 tan inverse x. To rewrite it further in a very categorized manner, you can imply theta is equal to tan inverse x. So you get y as 2 tan inverse x. So your differentiation now becomes a hell lot easier. You are given to find dy by dx. Now the differentiation of tan inverse x is 2 by 1 plus x square. Very simply, and this is what they want. Now coming to the next set of questions. Same as in question number 9, this also is something fishy. See, if you try to solve it in a general way, as tan inverse of something is the differentiation of tan inverse of something is 1 by 1 plus something square. Now if you want to do by that way in chain rule, you will be just screwed up. So the best way is to assume x as something. See here, if you can recollect that tan 3 theta is actually 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Don't you think that the same expression is given here, 3x minus x cube by 1 minus 3x square? So what you will do, you will be assuming let x is equal to tan theta, and then the whole expression, this whole expression will get reduced to tan 3 theta. Now tan inverse of tan 3 theta is 3 theta. So you will be just differentiating 3 theta with respect to x, and as you know that theta is equal to tan inverse x. That's how you will do the job. This is just coming to question number 11. If you observe properly, if you put x is equal to tan theta here, so 1 minus tan square theta by 1 plus tan square theta, you can easily break it down to 1 minus tan square theta times cos square theta, and that will be equal to cos 2 theta. So cos inverse of this whole thing will give you once again 2 theta, where x is equal to tan theta. So in the same way you can solve this. So basically, as you can see that if you put tan theta, it is a really very simple analysis of this trigonometric problems. Same is with 12 and 13. You can solve it your way. Now if I say about question number 13, y, as you know, so once again you will get this expression by putting x is equal to tan theta as cos inverse of sin 2 theta, but you have to have here sin cos theta in order to replace this. So what you will be doing is just transforming sin into cos. As you know that sin theta is equal to cos pi by 2 minus theta. In this way you can write it as pi by 2 minus 2 theta. Now just you can differentiate it in a simple manner. In question number 14, see, this is once again a bit strategic question. You can assume x to be anything, either sin theta or cos theta. So see, you will always be getting 2 sin theta cos theta as the answer. That means you will be getting sin 2 theta by replacing this expression, putting x is equal to either sin theta or cos theta. That's how you will be solving this question. And finally coming to here, sec inverse of this whole damn thing. Now this may look a bit unfamiliar, but if you look closely, sec inverse of anything is equal to, like, sec inverse of t is equal to cos inverse of 1 by t, right? So sec inverse of 1 by 2x square minus 1 is equal to basically cos inverse of 2x square minus 1. And if you look further closely, if you can just replace x by cos theta, you will be getting 2 cos square theta minus 1. 2 cos square theta minus 1 will be equal to cos 2 theta, and cos inverse of cos 2 theta is simply 2 theta. So you can differentiate it that way. This exercise was as simple as that. I hope you have no problem, because these are just repetitions. If you have any kind of problem, please feel free to use the comment section. I'll be meeting you in the next video, where I'll be discussing exercise 5.4. Thank you very much for watching this video.